Hello, Year 8. This is the Space Topic Lesson 2. This is Mr. Radmall, and today we're going to be talking about the solar system, and in particular, that question that students are always asking their science teachers: why is Pluto not a proper planet? So, can you write down the driving question, please? And the starter question is, can you guess how old our solar system is? We talked last lesson about how we came to our current understanding of the solar system. Now we're going to talk about the actual solar system. So, what do you think? How old is our solar system? 460 million years old, 4.6 million years old, 4.6 billion years old. Okay, so the answer is in actual fact 4.6 billion years ago. That's when the solar system is thought to have formed. That's quite a long time ago, even by the standards of the age of the universe. So let's talk about what the solar system actually is. So the solar system, as we've talked about before, it's got the sun slap bang in the middle of it, and then you've got various objects orbiting around the sun, not just the planets that I'm sure you're familiar with, but other objects as well. So the solar system is is the sun and all of the objects, including the planets, orbiting around the sun. And they're orbiting the sun because the sun's large force of gravitational attraction pulling on it, swinging all the objects around it in its particular orbits. So here is an overview of our solar system. We've got four smallish planets in the first four orbits. Then you've got an asteroid belt, lots of small rocks, icy rocks, in a ring orbiting around between Mars and Jupiter. Then you've got four much larger planets on the outer orbits. Then you've got a much smaller object, Pluto, more about that later. And then you've got another ring of very small icy rocky objects called the Kuiper belts orbiting around as well. Some of those objects actually as big as Pluto, for example, Eris. More about that later as well. So here, that's an overview of the solar system. Let's just have a look at the order of the planets of the solar system. Now, it is normally quite a good idea to be able to memorize the order of the planets. A mnemonic helps here. I use this one. Very useful, sticks in the head. So for the planets Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune and Pluto, I use the mnemonic. My very easy method just speeds up naming planets. That sticks in my head, and I always use that to try and remember the order of the planets in our solar system. Here are the planets again, and here I'm trying to show you what the relative distances are. As you can see here, Mercury, Venus, Earth, and Mars are relatively really close to each other, even though we're still talking about hundreds of thousands of miles between them. We're relatively close. Once you get to the larger planets, Jupiter, Saturn, Uranus, and Neptune, we're talking about much bigger distances involved here. Okay, so let's just sum up some of these ideas that we've just introduced. Have a read through, pause the video. Which of these statements is false? Which of these is a porky pie lie, which is East London slang? Okay, so the porky pie in these statements was, did you spot it? Yes, A, the solar system is the sun and all objects orbiting it, not just the planets, but asteroids and dwarf planets, and comets and all objects orbiting the sun, not just the planets. Okay, so let's talk about this one. The elephant in the room, the dwarf planet in the solar system, Pluto. So Pluto was thought to have been a planet up until about 15 years ago, when scientists started having quite a big heated argument about whether Pluto should be classed as a planet or not. And during this argument, they came up with three criteria that makes a planet a planet. So in order to join the Planet Club, you've got to be orbiting the sun, which Pluto does. Pluto does orbit the sun. Have sufficient mass, so be big enough. And Pluto also is big enough to be classed as a planet. But, and here's the crux of it. In order to be a planet, you also need to have a clear neighborhood around your orbit, which means that you're big enough that you've managed to clear out the orbit, the path around the sun. Okay, and this is where Pluto doesn't pass the test. And the reason why that is because Pluto's orbit does for part of Pluto's orbit, it enters what's called the Kuiper belt. So it actually enters into the ring of kind of huge numbers of objects, some of the same size as Pluto, and that's where Pluto was relegated to becoming a dwarf planet because it didn't have a clear neighborhood around its orbit like all the other planets did. So Pluto, even though it's large enough to maintain a spherical shape, it orbits around the sun. Unlike the other 8 planets, including our planet Earth, it does not have a clear neighborhood around its orbit because it enters the Kuiper belts and ends up with lots of other objects, some of which are the same size as Pluto. Here are some examples of some other dwarf planets that exist in roughly kind of same kind of orbit as Pluto. Eris is the biggest one. It's roughly about the same size as Pluto, and is a bit further out from the Kuiper belt. And then you've got some other examples of dwarf planets here as well. So again, pause the video. Why was Pluto relegated? Why is Pluto no longer considered to be a planet? Okay, so yes, it is B. It does not have a clear neighborhood around its orbit, meaning because its orbit enters the Kuiper belt and it ends up in and amongst lots of other objects, it is not classified as a planet. Poor old Pluto. Right, so final big idea about the solar system for us to talk about. Now let's talk about temperature and how hot the planets are orbiting around the sun. Now, as you can see here, look, here's the surface temperature of different planets of the solar system, and it roughly follows the order of the planets as you would expect. So the planets that are closer to the sun are hotter, planets further away from the sun are colder. Interesting that Mercury, which is the closest to the sun, isn't actually the hottest. It's Venus, and that's because Venus is able to trap thermal energy much more efficiently than Mercury is, and also can generate more surface temperature as well. But pretty much the order of the planets is the same as the order of the temperatures. Now, Earth sits in an orbit that's very convenient for life. And in actual fact, Earth is the only planet in the solar system which sustains life. And an important factor in that is the temperature of the Earth. As you can see, the average Earth's temperature is about 15 degrees centigrade. And other planets are either much hotter than that or much colder than that. So, I mean, why is this so important? Well, it's about water. So water freezes at 0 degrees and boils at 100 degrees. So in order for water to be a liquid, it's got to be at a temperature between 0 and 100 degrees. So, which is what Earth is. So that's why we can have liquid water on our surface. Okay, well, why is this important? Well, human organisms, and for example, humans, contain a huge amount of water as a liquid. And that's very important for life because our blood, which contains a lot of water and transports things around our body, really important things in order for our bodies to exist and live. Water is a very good solvent, and it's very easy for things to dissolve into it and then come out of it. Without water as a liquid, we wouldn't have blood, we wouldn't have a transport system, and life would not be able to exist. Okay, so this idea is linked to the old fairy tale. I'm sure you've heard of it, of Goldilocks and the three bears. Goldilocks, of course, invaded. How she technically broke the law, trespassed on the in the bear's house, and kind of like was a bit too nosy, and came across three bowls of porridge. One of them too hot, one of them too cold, and one of them just right. So our planet Earth occupies an orbit that is not too hot, so that water becomes steam, not too cold, so water becomes ice, but is just right for water to be a liquid. And that's a very, very specific place for our planet to be. So we're very lucky we've ended up here in that respect. And this is called the Goldilocks Zone. The Goldilocks Zone is a range of orbits around a star which allows water to be a liquid, not a gas and not ice. So the Goldilocks Zone, when astronomers are looking at other stars and looking for other planets, they look for planets in the Goldilocks zone when they're thinking about finding planets where alien life might exist, where water might exist as a liquid. So very quickly, this last idea, Goldilocks zones. Okay, pause the video. What's the definition of the Goldilocks zone? Okay, so hopefully you have chosen B, a range of orbits where water can exist as a liquid on the planet's surface, like Earth's orbit is in the Goldilocks zone. Okay, time to bring all these ideas together. So, can you pause the video now? Starting off with for describe, can you remember the order of the planets? Maybe using that mnemonic that I mentioned. My very easy method just speeds up naming planets. Can you define the solar system for explain? And can you explain why the solar system is not just the sun and 8 planets? Why is it not just the sun and 8 planets, as some people might have previously thought? Then for use, can you use your ideas about the solar system to explain why Pluto is not now classed as a planet? And then can you define the Goldilocks zone, and why is the Goldilocks zone so important? Why is it so important that Earth is in the Goldilocks zone? Okay, so pause the video. Okay, so let's go through some of these answers. So for describe, state the order of the planets. You've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And then we'll put Pluto in, even though technically it's a dwarf planet, Pluto. Right, definition of the solar system and why the solar system isn't just the sun and 8 planets. So definition of a solar system is the sun and all objects orbiting it under the influence of its gravitational field. The solar system isn't just the sun and 8 planets because other objects exist. These include dwarf planets, asteroids, comets, and the Kuiper belt that also orbit the sun. Why is Pluto part of the solar system but not classed as a planet? Well, Pluto is in the solar system because it is orbiting the sun, isn't it? So anything orbiting the sun is still in the solar system, but it's not classed as a planet because it does not have a clear neighborhood around its orbit. This Pluto's orbit enters the Kuiper Belt, which is a ring of objects orbiting beyond Neptune. Some of these objects are as big as Pluto, for example, Eris, the other another dwarf planet in the Kuiper Belt. And last but not least, the Goldilocks Zone. What is it, and why is it so important? Well, the Goldilocks Zone is a range of orbits that is close enough to the sun so the water doesn't freeze, but far enough so water doesn't boil. This means water can exist as a liquid. Water as a liquid is important for life as it is a solvent and can provide a transport system for multicellular organisms, for example, blood in humans. A solvent is a liquid which solutes can dissolve into to make a solution. Okay, so now it's time for you to think about where you are in terms of the solar system, what you are happy now explaining in terms of what the solar system is, why Pluto is not a planet, and why the Goldilocks zone is so important. So, can you copy and complete, please? Today, I've achieved a describe because I can state the order of the planets, and explain because I can define the solar system, a use because I can explain why Pluto is not a planet, and combine because I can explain why the Goldilocks zone is so important. And when you've done that, you are now ready to complete the Show My Homework quiz. And will be aiming to email communicating with your guardians or parents these quiz results. And that is why Pluto is not classed as a planet. Many thanks, Year 8. Stay happy and stay safe.